Hi, welcome. My name is Prashin Parik and today I am going to show you a machine learning project, Iris dataset classification. So let us start. Here is my Jupyter notebook. I am running it on VS Code. So one thing to run Jupyter notebooks, that is IPython notebooks, you need to have an extension installed, and just there you can search it. Search for Jupyter notebooks and you will get an extension Jupyter. Just install it and enable it so that you can run it efficiently. The code will be provided in the description, you can see it. And let's start. Let's talk about the dataset first. The iris dataset, iris.csv, consists of comma separated values. It basically has four important features: the sepal length, sepal width, petal length, and petal width, and the target species of iris flower, whether it can be setosa, it can be versicolor, or it can be virginica. Uh, our goal is to predict this species of the iris flower on the basis of these four features: sepal length, sepal width, petal length, and petal width. The data shall be provided along with this Jupyter notebook. To start, here it is. We start by checking our Python version. Most of us will have Python 3 and above installed. My version is 3.10.7. These are just some of the utility functions we shall be using. Say if you are writing Python code somewhere else and you want to import functions from there, so into the Jupyter notebook, you might need this. So just run as it is. These are not very important. The last one, perhaps percentage matplotlib inline. This will help to plot us graphs within our Jupyter notebook. So here are some of the standard library imports. Just one thing want to make sure is, if you don't have any of these libraries, say NumPy, Pandas, Matplotlib, or Seaborn, you might as well want to install them. You can do it on terminal or within the Jupyter notebook. Just type exclamation pip install the library name. If it is NumPy, then you can type NumPy or any else. We use these four libraries basically for performing data analysis. Sorry. NumPy stands for numerical Python. It helps us in doing linear algebra. It is pretty much useful for its object which it provides, the NumPy ND array object. Typically fast operations such as slicing, multiplication, matrix multiplication can be performed on those. Second one is Pandas, which stands for Panel Data Analysis. It is a library built on top of NumPy which helps us perform data analysis. It provides functions like, say, read CSV, read Excel, to read data from the CSV and Excel files into the Jupyter notebooks. It has basically two objects. The first one is a data frame, Pandas data frame, and the second one is the series. We'll look into it as we go into this. To install, or as I have said, to install, you can just install it by writing pip install whatever is the library name, say NumPy, then NumPy. It might not work like this in VS Code, so instead of exclamation you can just do a percentage symbol. Yeah. Matplotlib and Seaborn are some of the libraries which are used for plotting plotting the graphs. Another important library which can be used for plotting interactive graphs is Plotly, which we shall not be using in this course. Here it is. To run any cell, any particular cell in Jupyter Notebook, you can just simply press Shift Enter or Control Enter. So as I made you see the dataset, it consists of 150 records or rows, each of which consists of an ID, or you can say a serial number, to uniquely identify the record, the sepal length, sepal width, petal length and petal width. Based on these four parameters, we need to classify whether the species is of the type Setosa or versicolor or virginica. So this is a multi-class classification problem. We can use logistic regression, which is a binary classification problem. So we can just separate out two of the classes. Let us look how. First of all, loading the dataset. Let us load the dataset. So for the dataset to be loaded, we take a variable df, short form for data frame, pd, as we imported pandas, alias, this is an alias name pd, this is the standard imports in Python, and pandas offers a read csv function to read a data frame into a data frame. Here it is. I have in the same directory my CSV file in the same directory as this notebook, Jupyter notebook. So just running this will load into our df variable. Secondly, here we have df.head. What does this mean? This simply takes the first 5 records and shows it to us. Here it is, as you can see, in a pretty formatted way. These are the columns name and these are the row names. So to check which of the columns are present in our data frame, we can also use df.columns, a variable, the data frame dot columns, and we'll get a list or an index of it, say ID, sepal length, petal length and so on. The data type, D type of it, is an object. One of the most important Python libraries which we can use for machine learning is scikit-learn. Okay, we can import it from as sklearn. It is used as sklearn, scikit-learn. So iris dataset, being a very popular one, is also available on sklearn, and we can also directly load from scikit-learn library as shown. Let us try to run this. So from sklearn, we are not importing the entire library, we are just importing datasets from it. So, and yeah, our iris dataset can be loaded as load iris function with the help of load iris function, datasets.load iris. So we loaded a dataset iris into a variable data, and when we use this method dot keys on data, it returns a dictionary keys data target frame. Let us look into it. So this, using the DESCR key into our data, we can see it is giving us a nice description of the data set. Number of instances 150, 50 in each of the 3 classes, meaning as I showed you, there are 3 classes of species: Setosa, versicolor and virginica. We have 50 in each of the 3 classes. Number of attributes, 4 are numeric, predictive attributes and the class attributes. So what does numeric mean? Numeric means which can be measured in centimeters, meters, kgs, kilograms. So here it is: sepal length, petal length, sepal width and petal width in centimeters. The class or the species is an object or a string, as you can see: iris, setosa, versicolor, virginica. Let us move forward. Here one more thing is, it is giving us the summary statistics of, say, sepal length. The minimum sepal length is 4.3, the maximum is 7.9, the mean, standard deviation and class correlation. Let us look at some of the other keys. We looked at DESCR or description. Now let us look at, say, feature names. So This is the Python way of accessing feature names from the dataset load iris. Here it is. These are the feature names and some of the other things. So print data of data. This prints the 150 records of the 4 numeric features. Sepal length in centimeters, the first column. Sepal width in centimeters, the second column. Petal length in centimeters and petal width for 150 records. So let us look at the problem which we are trying to solve. Take a look, have a look on your screen. Basically, we are trying to predict the species on the basis of these 4 features: sepal length, sepal width, petal length and petal width. So this is a multi-class classification problem. So before we can proceed any further to build our model, we shall do some exploratory data analysis on it and find the summary statistics. So remember the df variable, the data frame which we loaded a CSV file into. Here, let us have a look on it by running the info method on it. There are 2 methods, info and describe. Let us see what those do. So this info method gives us the column names, how many count or non-null values and the data type of it. ID, as you can see, is an integer column, int 64, 1, 2, 3 and so on. The sepal length centimeter, sepal width centimeter, petal length centimeter and petal width centimeter. These are floating point numbers as it is evident from here due to the decimal point. And the species, finally there is a species. You can say it is a string, or in Python it can be termed as an object. So as here you can see, as we described, there are 150 values in our or records in our dataset or CSV file, and there are 150 non-null values, meaning there is no null value or something which is termed as void. So this reduces our work in data analysis. Here it is, we find 0 null values, which means our dataset does not contain any null values. Now let us have a look at the species column. These variables in the species column, Iris setosa, Iris versicolor, Iris virginica, we can rename those by writing the following line of code: df species equal to df species dot replace. So what do we want to replace? We want to replace a list which contains the 3 names or the 3 strings, Iris setosa, versicolor and virginica, with the variables or the integer type 0, 1 and 2. So this helps us a lot. Let us see how. So it has replaced Iris setosa with the number 0, Iris versicolor with the number 1 and Iris virginica with the number 2. So given a random set of tuple of 4 floating point numbers, say sepal length, sepal width, petal length and petal width in centimeters, we need to predict whether it is setosa, versicolor or virginica, or as we have renamed those 0, 1 or 2, where 0 represents setosa, 1 versicolor and 2 virginica. We can also rename the column, as we can see sepal length centimeter, centimeter. We know it is in centimeter, so we perform the rename operation over here. So let us perform the basic descriptive statistics on our dataset by using the describe method. As you can see, this describe methods gives us the 5-point summary: the minimum, the maximum, first quartile, median or the second quartile and the third quartile. Here it is, first it returns the count, means the number of non-null values, 150 as we saw earlier. It returns the mean. What is the mean or the arithmetic mean of the numeric types? What is the standard deviation? The minimum. Here the minimum in sepal length is 4.3, the maximum is 7.9, and quartile 1 or the 25th percentile is here. median or the 58th percentile, and so on. Now let us say the distribution features. Now let us plot graphs to see what kind of distribution it is. It is normal, Gaussian, or whatever, say uniform. Let us have a look on it. So firstly we would like to have a look on the sepal length. So for the 150 records, what is its distribution? We know the minimum is 4.3 and the maximum is 7.9. So let us have a look. So for this we will be using a histogram from the matplotlib.pyplot library. Here it is. It has plotted a histogram. Second, we'll try for sepal width. Again, see, sepal width. The minimum is 2 and the maximum is 4.4. Let us verify using the graph. The minimum we can see is 2, the maximum say less than 4.5, it's 4.4, yeah. And can you see it's looking something like a normal distribution with the highest frequency in the middle and less in the corners. Next we'll look it for petal length, the same procedure, plotting a histogram. So here it is, we can see some of these high frequencies over here, starting from 1 till something less than 7. I'll repeat it for petal width as well. Petal width. Okay. So species name, here it is, we can also add another column, species name, mapping 0 to setosa, 1 to versicolor and 2 to virginica. Let us plot a relational plot with or a heat map by which we can see the correlation between the columns. Say the first column is a numeric column, the sepal length and the species. Species in the sense setosa, versicolor and virginica. So here it is, the graph. We plotted using Seaborn, another Python library which is used for helping us in plotting the graphs. Here it is, the species. As you can see, we mapped 0 to setosa, 1 to versicolor and 2 to virginica. There are only 3 horizontal lines, 0, 1 and 2. So blue color represents setosa, orange for versicolor and green for virginica. On the basis of sepal length, can you see? Say something has 4.5, a flower or the sample has 4.5 as its sepal length. So it can be classified as setosa. This is on the basis of a data set. Okay, have a look on it. Now let us try for sepal width. Okay, setosa, versicolor, virginica. Now for petal length. In this graph we can see an interesting trend. Now what is it? Say if the petal length is less than 2, here it is, we can correctly guarantee it as it will be setosa. So this was the interesting point to be noted over here, as a vertical straight line can be drawn from here between say 2 and 3, and below 2 or somewhere near 2 it can be classified as setosa. So now a problem can be termed as a binary classification between versicolor and virginica, as we have already classified setosa flowers based on their petal length. This was an important point to be noted over here. Let us move to the next one. For petal width, again similar thing happens for petal width. We can plot a vertical graph, vertical line through here somewhere between 0.7. So we can classify less than that vertical line as setosa, but not truly for this pair, Virginica and Versicolor. Yeah. Let us have a look at pair plots. So Seaborn library offers something known as pair plots, and you can see it over here. The code is running. It will be ready in a short time, I think. Mm, okay, let it be.